Alright, so yesterday we started developing the unit circle, yes? Okay, alright, and so we developed the unit circle and we worked on it a little bit and we developed 4 points on the unit circle. We said that we had that point, that one, and this one down here. So I'll start down here. So that was the point 0, -1, which also was 270 degrees or 3 pi over 2 radians. Yes? And then over here we had this one was the point -1, 0, and that was 180 degrees or pi radians. We had this one over here, which was the point 1, 0, and that was 0 degrees or 360 degrees, and 0 radians or 2 pi radians. Yes? And then we had the point straight up, which was 0, 1, which was 90 degrees or pi over 2 radians. Yes? Okay. And then we ended class by saying I wanted you to figure out this triangle and figure out the coordinates of that point up there, given the fact that this was a 45-degree angle and the hypotenuse was 1. Okay? Did anybody come up with coordinates?
I didn't come up with a coordinate, but in order to find x, would you cosine 45 equals x over 1?
Yes, you would. Yep. Okay. All right. So that's one method. We could use SOHCAHTOA, right? So one way of doing this would be that the cosine of 45 degrees is equal to x over 1. Also, the sine of 45 degrees would be y. 2 over 1. I was trying to get it in and I was trying to get it paused, but it just didn't work out. Okay? Right? That's one way. Okay? What's another way? There's 2 other ways that I know of. Because this way, if I type this in on a calculator, that's just going to give me that 0.7071 stuff. But that's rounded. I don't want rounded. I want exact. So the other 2 ways are, it gets me the exact answer. It gets me the root 2 over 2 answer.
Is that yellow triangle?
Same thing. Yep, same thing.
Oh, it's the same as what you wrote down?
Yep, it's the exact same thing. Yep. We just gotta figure out different ways to get to it, because there's 2 more ways. Can I use the Pythagorean theorem here? You think so, or you know so? Why do you think so? It is a right triangle, so technically we should be able to use the Pythagorean theorem, but the downfall is that I don't know 2 sides. So I have 2 unknowns in one equation, and that's just not going to work out. Or do I have 2 unknowns? What? Why are x and y the same? Because it's a 45, 45, 90 triangle, so that's an isosceles right triangle. So that, therefore, x and y are actually the same here. So we could have said x squared plus x squared equals 1 squared, or 2x squared equals 1. So x squared equals 1/2. Take the square root of both sides, and we get x equals 1 over the square root of 2, which when you rationalize your denominator gets you the square root of 2 over 2. Okay? That's another way of doing it. The last way is you had to remember back when you were a tree. Okay? Back when you were in geometry. I'm a tree. Okay? And the formula, the shortcut, if you will, is that in a 45, 45, 90 triangle, that the hypotenuse is equal to the square root of 2 times a leg. Or that the leg is the hypotenuse divided by the square root of 2. So then that would put you here, which then when you rationalize it, puts you there.
Can you explain how like the 1 over the square root of 2 is the same as the square root of 2 over 2?
1 over the square root of 2 times the square root of 2 over the square root of 2. That fraction's equal to 1. Gets me the square root of 2 over the square root of 4, which is 2.
Because you don't want the square root in the bottom?
Correct. Okay? With me? So knowing that fact, now we can go back. Actually, let's go forward here. So now let's put these points in. Let's go black for these points. Okay? So here is this point, which is now at the square root of 2 over 2, comma, the square root of 2 over 2. What is the degree of that theta? 45 degrees. What is the radian of that theta? What you got? It is pi over 4. With me? Okay. Now, let's flop that triangle over to here. What's the coordinates? Comma. Okay. Because this is quadrant number 2, and all points in quadrant number 2 have to be of the form negative, comma, positive. Just like everything over here in quadrant number 1 has to be positive, positive. Okay, let's talk degrees. So we went 45 degrees to here. Then we went 45 degrees to here, which got me 90. Then we go 45 more degrees, which is 135 degrees. In terms of radians, we went pi over 4 to here. 2 pi over 4, which reduces down to pi over 2 to get to the 90, or to get straight up. So how many pi's over 4 do we have now? We're at 3 pi over 4 radians there. Okay. Let's drop that like it's hot. Let's drop down here to there. What's the coordinates of that point down here? Remembering that we're in quadrant number 3 now, so they both have to be negative. So the coordinates are fantastic. Okay. Degrees, 225. Radians, What do you got?
5 pi over 4.
5 pi over 4. Good stuff, isn't it? We don't have a Festival Foods around here, but Festival Foods' slogan is great stuff for not a lot of money. You're getting great stuff here for not a lot of money. Festival Foods. Okay. Now let's go over here to our last one. Coordinates.
Positive square root 2 over 2. Common negative square root 2 over 2.
Degrees. Not 330. 315. Radians. Bingo. Emily, would have you understood if I would have said bingo and bingo was mango? Making sure. Okay. And we're good to go, right? Okay. All right. I like it. Some might say I like it a lot. I just watched that movie this weekend. It was good. I haven't watched it in a while. What movie am I talking about, of course? Dumb and Dumber. Want to hear the most annoying sound in the world? All right, so now let's go with our sixths. Let's fill in some more here. So I'm going to go with this one as my triangle now. Okay, so there's my triangle. I still have a radius of 1, but now this is 30 degrees. So what I would like you to find now is I would like you and somebody close to you find me X and Y for those two. Okay? Go for it. Anybody coming up with it? No, it's not working. Now it'll work. Oh, see, now I gotta go one more. There we go. Okay? You gotta remember your 30, 60, 90 relationships. Okay? So, in the 30, 60, 90 relationships, okay, your short side is across from the small angle, and your long side is across from your 60-degree angle. Okay? So the two relationships are that the hypotenuse is equal to twice the short leg, and the long leg is equal to the square root of 3 times the short leg. Okay? So with that being said, our hypotenuse is 1. So then what is y? If it's 2, then it's longer than the hypotenuse. Remember, the hypotenuse has to be the longest side. 1/2. Okay. What then is x? So our short side was 1/2. Our hypotenuse was 1. So what then is our long side? Could we call it the square root of 3 over 2?
Yes.
I would love it if we called it that, because it makes it easier. It makes it be a fraction. Okay? All right. So let's go to the unit circle now. We'll put these in purple. Okay. So this now becomes the point, the square root of 3 over 2, comma, 1/2. In terms of degrees, we said that this was 30 degrees. In terms of radians, that's pi over 6. Agree? Okay. Now, if I take this triangle and I flop it over to this side, the math is still the same, except I'm here now. What is the coordinates? Degree-wise, what degree am I at? Not 120, nope. Because my 30-degree angle is now here. That's my 30-degree angle. So if this was 180 out here, what's this up here? 150. In terms of pi, how much? Or in radians, I should say. Not 5 pi over 8. 5 pi over 6 I like better. Okay. Now let's go down here. Coordinates. Degrees. 210. Radians. Say louder, Hale. It is 7 pi over 6.
How do you get that?
Because each of those angles is pi over 6, right?
Oh, so this is 1 pi over 6.
Yep.
Okay.
Okay? But no, you got it. So this angle right here is pi over 6, right?
Okay. Yeah.
Which means, so that's why it's pi over 6 there. Okay? This angle right here is pi over 6, yes? Right?
Yep.
But this over here is pi. So 1 minus 1/6 is 5/6.
Okay.
Okay? Down here, this angle now is pi over 6. 1 plus 1/6 is 7/6. Okay? Now we'll blow your mind. We'll see if you can get it now. So now I'm over here. Positive square root of 3 over 2. Negative 1/2 for my coordinates. Agree with that. Degrees. 330. Radiant. What do we got for radians? I know I wrote it up there, but 11 pi over 6. Because 2 pi is how many 6? Or 2, I should say, is how many 6? 12. I got to take 1 away. That gives me 11 pi over 6. Okay. Other way, convert 330 degrees into radians. You get 11 pi over 6.
I can do that.
Easiest way to. Okay? Alright? Which you could have done with any of these two. As long as you know what the degree is, you can just convert it. Multiplying it by pi over 1/8.
Right.
Okay? Good with those 4. So now we've got 12, right? Because we've got our blue ones. We had those. And did I go with blue on the other ones too? Nope, I went black. And we got our black ones. Okay? So now we just got to get the other ones, right? Okay, let me see what my next slide is. And it's that one. Oh, okay, so I got to go back to we'll go back to this one. So now, actually, let's go back to this one because it's cleaner. Okay, so let's go in this color and let me erase all of this. Okay, so now I want this one. With that one, this is now a 60-degree angle, which makes this a 30. Oops, that's a bad 3. Oop, that's not going to work. I got to go smaller than that. There we go. Which makes this a 30-degree angle. There's my right angle. I still have a hypotenuse of 1, correct? Which means now this is going to be my side length, that's 1/2. And this is going to be my side length, which is the square root of 3/2. Correct? Alright? So all that math was the same from that. Okay? So let's fill those points in now. So this one we said was 1/2, comma, the square root of 3/2. In terms of degrees, it was 60 degrees. In terms of radians, 60 degrees is pi over 3. Transfer that knowledge over to this point. Coordinates, -1/2, comma, positive square root 3/2. In terms of degrees, 120 now, right? Because now we're going up by 60s. In terms of pi's over 3's, we're going up by pi over 3 every time, right? So it'd be 2 pi's over 3. 2 pi over 3 plus pi over 3 gets me 2 pi over 3 plus another pi over 3 gets me 3 pi over 3, which is pi. I've already done that one. Okay. Pi plus pi over 3 gets me 3 pi over 3 plus 1 more pi over 3 gets me 4 pi over 3. So this one's going to be at 4 pi over 3 radians. The coordinates of this point are going to be negative 1/2, comma, negative square root of 3 over 3, or square root of 3 over 2, excuse me. Degrees, 240, because we were at 180, plus 60 more is 240. Plus 60 more is going to be at 300 degrees, right? The coordinates of that point are going to be positive 1/2, comma, negative square root 3 over 2. The radian of that one is going to be 5 pi over 3. Okay? So now you should have a completed unit circle on your page that looks like the top, well, so you can really only see the top half of that one. Actually, I think I could probably shrink it. There we go. Now it fits in on one page. So your unit circle should look like that, where you've got the coordinates of your sweet 16, you've got the degrees of your sweet 16, and you've got the radians of your sweet 16. Okay? Now, where we're going to use that is we are going to use that to shorten things up for us. So, for instance, we can look at, oops, I forgot to put the shade on this one. We can look at the sine of pi over 6. Now, from yesterday, we learned that x is what? X is cosine, y is, tangent is y over x, right? So sine over cosine. Okay. Secant is what? Reciprocal of x. Yep, inverse of x. Cosecant is reciprocal of y, inverse of y. Cotangent is reciprocal of the tangent, or x over y, right? Okay? So we can go to our unit circle and we can say now the sine of pi over 6 is the y part, or of the coordinate of a radian degree of pi over 6. So the y part is 1/2. So this becomes here 1/2. Okay? You try the other two. All right? So the cosine of 4 pi over 3. 4 pi over 3 is down here. So the cosine of 4 pi over 3 is going to be the x value, right? At 4 pi over 3, so I get negative 1/2. Tangent at 3 pi over 2, we said tangent was y over x, correct? Okay, so I look back at y over x. So that's going to be negative 1 over 0. Is that possible?
No.
No. So this one is what we call undefined. Okay? Not 0, undefined.
If you write not possible, is that going to work?
That would work too, but I prefer undefined.
Okay.
Okay? All right. Try those 3. So the cosine at 7 pi over 6, I'm actually going to work right to left. Okay? The cosine at 7 pi over 6 is going to be the x value of that point, correct? Okay? So that is going to be negative square root of 3 over 2. Do we agree with that one? Okay? The cotangent at pi over 4 is going to be x over y. So that's going to be the square root of 2 divided by 2 divided by the square root of 2 over the square root of 2, which is 1. Okay. The tangent at 5 pi over 6 is going to be y divided by x. So that's going to be 1/2 divided by negative square root of 3 over 2. Agree with that? Which is 1/2 times 2 over negative square root of 3. Multiply by the reciprocal, which is negative 1 over the square root of 3. Now, if you wanted to rationalize that denominator and put that one as negative square root of 3 over 3, I'm okay with that too. Okay? Those two mean the same thing. Okay? In terms of the unit circle, Mrs. Hill and I are not necessarily strict with rationalizing the denominator.
How do you get to the brownish color one from the green? Negative 1 over,
This one?
yeah.
2's cancel.
Oh, okay.
Multiply across.
And then the negative just goes on top.
It can go on top, it can go on the bottom, it can go out in front.
Okay.
It can only go in one of the 3 spots.
Right.
Okay? Handle? I remind you again that tomorrow and Friday you will need charged Chromebooks, okay, with earbuds. In terms of homework, if you are one of those that needs to do homework or just likes doing the homework to get more practice on this, you could start the 4.3a homework now. Okay? Thanks for playing along.